Good morning, good afternoon, good evening. Welcome to your module 3 of the 3 months hands-on certification program in pharmacometrics and PK/PD modeling using R, S, and LME. So last week, we actually started our module 3, which is the R, S, and LME section of our workshop. I know last week we had Keith who covered some basics and fundamentals of RS and LME. He also walked us through a few scenarios on how to use this tool. And we had homework assignments that you all had to work on. And today's main focus would be to go over those homework assignments. We would also like to hear from you about, where were you able to solve them, or what extent were you able to solve them? What kind of, we are here to get your feedback and also to see how we can support you. Well, again, I also do want to acknowledge that this is the first time you're working with this new tool. All of us are completely aware that you may not have been able to solve through the entire homework assignment, but we would like to hear from you about what part got done, what part was easy for you to get, and where do you need our help and support. And again, like always, please raise your hand so one of us would be able to unmute you. If you want to share your screen, we can make you a co-host so you can show us your environment, show us where things didn't work for you. So Keith can help walk you through. We have Keith, Anna here, both of them can help you to walk through those hurdles that you had to deal with.
Okay, so should I take over from here, Runa?
Yes, please, Keith.
Okay, great. So I'm very flexible in terms of how we handle today's session. I can either walk through the homework, or what I'd prefer is if someone who was able to do at least some of the homework might raise their hand and then kind of step the group through the various questions. So do we have any volunteers? I'm happy to, discuss any questions as we go forward. Again, I'd like to keep this session flexible.
Keith, as we get warmed up, maybe we can ask some questions to the participants. So I might raise some questions. Would that be
okay,
helpful?
Anna?
Okay. If that's the case, maybe what we can do is let me share my screen for a minute. Aruna, is it possible for me to be able to share screen?
Yes, Anna, you are a co-host.
Okay, great. Thank you. All right. So what I thought might be helpful to just get folks here kind of okay, let me. So we can run a couple of questions to see how folks understood some of the concepts. So if you wouldn't mind, you can either do it on your phone or you can do it in the computer. If you go to this site, www.menti.com, and enter this code or just read this QR code, we can start kind of like some questions and answers. Okay, so I'll give everybody some time to do that.
So also, Anna, would you prefer that they go through this app, or can they also put their questions in the chat box?
Oh yeah, our questions can be in the chat box, or they can unmute themselves. It's kind of like a poll where I'm gonna be asking questions and they have to answer true or false. And then that will generate some discussion.
Oh, got it. Awesome. So again, reiterating what Anna mentioned is to go to this app. As Anna is asking questions, you could just pick yes or no for the answer. That way, we will be able to collect a poll and help you with wherever you are.
So Anna, it's
Yes.
saying that the code could not be found.
Okay, just give me a minute then. I'm going to start this. So just, okay, what about now?
No.
Right. Okay, so this is not working very well. Give me 1 second. All right, so I might need to send you another code, I guess, when we start this code. All right, I'm gonna put in the chat the code. Okay. All right, did you guys receive that?
Not yet.
Okay, I'll put in the chat also the link, the direct link that you can use.
I don't think we're seeing your messages in the chat, Anna. Not sure why.
Oh, I'm sorry. I think I'm sending them. Wasn't sending them to everybody. Okay, thank you for pointing that out. Okay, they should be coming through now.
Maybe post the code too.
Yep.
There it is. Okay. Okay.
Is that coming through?
Yes.
I know a couple of you have just joined. Wanted to bring you up to speed. In the chat, you would see a link. So please click on that link or go to the website, which is in the chat window that Anna has put in, and use that code that has been provided. We are currently in the process of doing a question answer session. This way, Anna is going to be able to collect a poll, and we would be able to see where you are in terms of the understanding of the homework assignment and or other related questions.
Okay, so I see folks that are already answering. All right, and maybe I can share these as this comes through. So let me share so everybody can see the. All right, hold on, give me a second. Okay, can folks see the tally here?
Yes, Anna.
Excellent, fantastic. Okay, I see it that it's still moving, so we'll give participants a little bit more time. So the first question is that to use the RSNLME textual model builder, which was that our Shiny app, I need to launch it within Piranha. And I see that 31 participants have answered these. Okay, and it seems to have stopped. Is this a good time to have a discussion? Oh, there's a few more answering now.
So we actually have 43 participants. So we have a few more who are yet to answer these questions.
Okay, so we do one question at a time. So I'll just be walking you through it. All right. Sometimes folks have issues with the app and we cannot expect 100% participation.
Sure.
Okay. All right. So let's start with the first one. And you can see here that 85% of you answered this true and 15 answer false. The correct answer is actually false. And we probably didn't do a very good job explaining these. Now, you can definitely launch these RShiny app, the RSNLME textual model builder from Piranha. And that is the way that we showed you because it is the most convenient in order to track the work that you're doing and be able to follow the workflow and be able to compare models, etc. However, there is no limitation to doing that. You can launch this within R directly. So this does show us that we probably didn't do a very good job explaining that. It is not the way we showed it, but we do want to be clear that these apps can be, these RShiny apps can be launched within R. Keith, is there anything that you would like to
Yeah,
add to that?
so again, RSNLME is a command line language that allows you to run pharmacometric models in R. We use Piranha as a front end to that. So any of the, not any, but the Shiny apps that we launch from within Piranha are actually their R code tools. And each one of those, if users choose not to work with Piranha, like advanced pharmacometricians very often work directly from the command line. And while Piranha is a very useful tool, they have built, workarounds that allow them to work efficiently, kind of custom workarounds. The Shiny apps that you launch from Piranha, we allow them to be launched for Piranha so that users who don't know R can use R to do this kind of work. And also these apps return the command line language that can be run at the command line. So sorry if that wasn't clear, but I think it's kind of a fundamental concept for the way we've built these tools. In terms of being, providing key applications that support kind of the core elements of the workflow and building those in a way that you can do the job with the GUI environment. But should you want to transfer everything over to the command line, you get a good example of the code for how to do that. So.
All right, sounds good. So I hope that was cleared. Are there any other questions on the chat? Reference to this? If not, we can do a couple more questions. And Keith, let me know when you think maybe we should stop and give more time to the homework. But this is just to generate some questions and make sure that folks have understood some concepts. Okay, so the next question is, I can edit the PML code within RSNLME textual model builder. Okay, I see we have already 24 people. We expect around 33. Okay, a couple more. Please submit your answers. Okay, so we're going to move on. This is fantastic. 93% of you got this right. This is true. Even though the textual model builder gives you a lot of library models that already pre-programmed the code for you, you can edit that code if necessary. Keith, is there anything else you want to add to that?
No, you can move on from this one. Yeah.
Okay, fantastic. All right. So I don't know if you can see it too well here, the code. May have to maybe increase the size, but I'm going to give you some time to take a look at this PML code. And based on that, you're going to determine if this is a true statement. The first question is, this is a population model. Is that true or false? And I think if I go like that, I don't know if that's any bigger. Okay, give everybody a little bit of time here. Please go ahead and submit your answers. Okay, I think we have 25 that have answered. All right, and this is the tally. I still see some folks submitting the answer, so I'll wait. Okay, seems like this is a good example. 83% of you said this is a population, 15 said it wasn't. So I want to make sure that we are clear with that. This is, yes, as a population model. And why is it a population model? Well, when we do population model versus individual models, we are modeling between subject variability. And as Serge explained in the first lecture, that is those concepts of ADAS. And as you can see here for these two parameters for Ka, volume, 3 parameters, and the main clearance, we have this exponential to the eta. So this is modeling the between subject variability for these 3 parameters. And therefore, this is a population model, a population PK model. anything else to add, Keith?
No, not on that one.
Okay. So we're going to continue with the code, this code that you have been reviewing. I'll ask you another question. So based on this, the structural model is a one compartment extravascular model with clearance parametrization. Okay, please finish submitting your answers. Fantastic. So the majority of you got this right. I see at this point we're about 76%, 77. This is false. This is not a one compartment. This is a two compartment. And you can tell here by the number of derivatives. So we have this compartment 1, A1, and compartment 2, A2. And that's also the reason why we have these parameters and a volume for one compartment and a volume for a second compartment. Now there's a derivative for the absorption compartment, but we're only counting that. We usually don't count the absorption as a one compartment, even though we have a derivative for it. So we call this a two compartment extravascular model. So everything was true here. It was an extravascular model with clearance parametrization, but it was a two compartment. And most of you got this right. Okay. Unless there's questions, we will move on. Okay, let's answer another question with reference to these. No between subject variability will be estimated for the intercompartmental clearance based on this code. And this should probably be our last question. I have a few more, but Keith, I think we should give some time for the homework. So we'll have these as our last question. Okay, please finish submitting your answers. I'm gonna do a review now. All right, so excellent to see. The majority of you understood these. It is correct. No between subject variability will be estimated for the intercompartmental clearance. So the intercompartmental clearance is that exchange between the two compartments, and we represent this by CL2. And you can see in the code here that it's only estimating the typical value of CL2. It doesn't have that exponential eta, which estimates between subject variability, and therefore no between subject variability in this particular model is going to be estimated for intercompartmental clearance. All right, great. Well, thank you for participating. Maybe these generated a few questions or discussions that we can talk about. And I'll stop here because I want to make sure that we have time to go through the homework assignment too.
All right, perfect. Thanks, Anna.
Welcome.
So do we have any volunteers to step through the homework with the group? Again, there's no silly questions. There's no wrong answers. I'd like to just open this up and keep it completely flexible. I see someone has their hand raised. Was that Nilesh?
So Nilesh, you would have, yeah, you are unmuted. So please go ahead and ask your question.
So Keith, actually the model with the software didn't run in my system and there were some technical issue, and I contacted Molly also, and still it's not resolved, so I could not complete the homework. But I do have a few questions, like do we need to use this parameterization in terms of clearance and volume for this population model, or can we also use the micro constants in this model?
So within the PML language, and Anna, please chip in if I don't answer this completely. Within the PML language, there is a library of models. I think there's over 100 models that can be specified through the combinations that are available in PML. And for the ones that can be written, in equations and not through differential equations, they will tend to run a little bit faster. And so yes, they can be written in different formats. You don't have to use differential equations.
Yes, but I'm asking about the parameterization. Like we have a micro constant like K1 to K21 parameterization in equation, and clearance volume parameterizations.
Yes. So, yeah. Okay. I get the question. So maybe I can. So it's possible to do that. And what I'll do is let me share my screen. Screen one. Share. So for example, I'm in the homework area right now. I created a project for the homework. Can everybody see my screen?
Yeah.
Okay, so if we go to new model, and we'll just use the model builder to do this, and I will select my pkdata.csv data set. And I'm going to run the model builder. So we'll take a second to load. And again, we're launching this from Piranha. This tool can also be launched from the R command line. So in the example that Anna showed, we had a 2-compartment model. Under options, you have the ability to parameterize. Here, the default is clearance. But if we look at PML, we can parameterize in terms of microconstants. And this would be the resulting code. So I apologize you weren't able to get the software up and running. Configuration of R can be tricky independent of RSNLME, and I would just ask you to continue to work with Mooley, and if we need to, we can bring in some of the developers. There's cases where package dependencies in R have trouble loading based on settings in your environment, and in some cases you need to create a custom environment to load the packages to. But again, we'd have to get our developer guys in. So does this answer your question?
Yes, so this was my question. So we can run the population model with any parameterization, right?
Absolutely. Yeah, PML is very flexible in that respect. So you see what we have: clearance, parameterization, micro constants, macro constants, and macro one is actually a slightly different one. I think this one brings in a volume term. Yeah. So.
Yeah, my another question is about, do we need to provide initial estimates before fitting our model? So you showed us that we have to first go to the initial estimator and then get the initial estimates and then go to the fitting of the model. So can we skip the initial estimate if we already have some idea? And can you show us where to put those initial estimates in the model?
So ideally, when you're doing population modeling work, right, you want to start with initial estimates that you know should be in the neighborhood of where your solution lies. So very often when you embark on one of these types of analyses, you do have previous studies where non-compartmental analyses were conducted. So you have an idea what clearances and volume should be. With a population model, the ability for the algorithm to converge on a good solution depends on a couple of things. If you have a very, very rich data set, then there's plenty of information to inform the parameters in that type of model, and that your initial estimates aren't so critical there because you have so much data that they could be way off, and the program will say, wait a minute, I have all this data, this parameter can't possibly be true, and it'll bring it to where the solution lies. If you have data sets that are more sparse, which again, this is why population methods were developed. Say it's a pediatric study, you can't stick the children very often to get blood. Then your initial estimates, you need to try to get them closer to where your solution lies. So some previous work in NCA is generally advisable there. Does that answer your question?
Yeah, so I'm just asking, can we, if we already have the initial estimates with us, with some regular fitting of data, can we skip that step and just include the initial estimates like during building our model and directly go to the fitting exercise?
Absolutely. Yeah. So you could either enter the initial estimates in the model builder as you build a model, or for any model that's created, you can just double click on it. And you see here, we have our fixed effects. These are editable. So, we can change this to 20, right? So you can edit it here. You also have the ability within Piranha and from the command line to run the initial estimates Shiny app. So this is a application. I didn't cover it in the lecture, really, because there's a lot of material already. But this is an application that will take your initial estimates, your model, and your data set, and allow you to make adjustments. So just bear with me. So you can look at one ID at a time. You can also overlay. Here we're looking at C versus time. And essentially we have sliders here. You can adjust the the duration of the fit you're looking at here. It's 24 hours for this particular data set. And then you have sliders for your parameter estimates. So this actually looks pretty good, but if you needed to move these around to get a better fit of the curve to the data initially, you just adjust these sliders, hit save and exit. Now notice this is now 21.3 for volume and 3.6 for clearance. Save and exit. And this comes back to Piranha. And what this has done is it's updated your parameter estimates here. So there's a couple of different ways to set your initial parameter estimates. Does that answer your question?
Yes, yes.
Okay.
Yeah.
Just
Yeah,
close that
because
out.
I was able to open the model builder with this software, but the initial estimate was not opening. Even the fitting of meta model was not opening.
Okay, Nilesh, again, I want to put you in direct contact with one of our developers who can help you get this up and running, because again, we have run into, some issues with individual configurations or company security like conventions that we've had to work around, but I'm certain we can get you up and running. Yeah.
Yeah, sure. Yeah. Thank you.
Okay. Back to the Zoom. Are there any volunteers to step through the homework, or would you just like me to kind of go through one by one the questions? I'll give it anybody?
So I see
No
that
volunteers.
Ramya says that Ramya, do you have a question, or would you like to walk us through any of the sections that you have worked through? Please raise your hand. I will be able to unmute you. You should have received a prompt, Ramya.
Yes, yes, sir. Like, hello, Keith. Like, I was able to develop a model in Piranha, but when I tried to use fit model, it was showing an error like some GCC was not found, like that. So I even contacted Dr. Mauli. We had a session, like even he was telling that there was a configuration error, and he told he'll get back to me. So I was stuck there.
Okay, so it seems like we had a lot of issues with installation. So perhaps again, please continue to work with Muli. I'm certain we can get you set up and running. Yeah, unfortunately, our configuration, the learning curve behind Usevar can be quite steep, and for an introductory course, perhaps it is a lot to to cover. I think the message that I want to give to the group is that we hear you loud and clear with respect to the difficulties in the installation, and we are going to take a look at how we might be able to simplify that a bit. One of the things we are looking at is a Windows type installer for the NLME engine component of the software. But I think, recall that we interface with R and RStudio. We can't control all the flexibility on that side of the environment, and sometimes there's issues that come up that are related to individual PC setup, so it's very difficult for us to control, but we are definitely looking at how to make this installation easier. So it seems like perhaps what I should do is step through the homework myself one by one. And really, if anyone has any questions, by all means, raise your hand and we can stop and dig deeper into a topic. And I think that would be a good use of the remaining time. And of course, if anyone has any questions, continuing moving forward, please contact myself or Muli. Does that sound okay?
Yeah. Yes, good.
Okay. All right. So what I'll do is I'll just step through the homework one piece at a time. So we have this data set, pkdata.csv. And the first question is explore the data set with the Piranha Data Inspector. So maybe what I'll do is I'll just start from scratch. So I do have this homework directory that I can refer to, but what I'm going to do is go ahead and just create a new directory and show from the very beginning how this would be done. So I'm going to go into my project D area and I hit new folder, and I'll just call this homework 2. Homework 2. So I have a directory. Right now it's empty. And what I'm going to do is go back to my Word, open up this pkdata.csv file. Here's my file. And I'm just going to save as, and then go to my project D folder. So, see data. Project D, homework 2. Hit save. Okay, now we can close this out. And within Piranha now, I can navigate to that homework 2 folder. So right now, if I hit refresh, I should have what happened here. Try this again, copy. I think opening it from within Word, there may have been some issues there. Paste. It saved it with a funny name, so I'll just delete that one. Okay, there's my PK data set, my pkdata.csv. So if I refresh, so empty project in Piranha, all I have is a data set. And if we go back to the homework, explore the data set with the Piranha Data Inspector. And we're looking for 2 errors in the data set. Can you spot them? So go back to Piranha, and to open this file in the Data Inspector, you simply right click on it. There's a couple ways to open it, actually. You can open it in the Data Inspector. You could open it in Excel. You could bring it directly into R from Piranha. Again, there's flexibility within here, but what we're going to do is use the Data Inspector. And again, the Data Inspector in Piranha is a very quick and dirty way of taking a quick look at your data set. Very often the first time you have a first version of a PK data set, there's going to be errors in it. And the goal before you start your 50 to 100 run population analysis, you want to make sure that you have a clean data set, because you don't want to redo that work if your data set changes. So this is the Data Inspector, and it's quite intuitive. You have time, concentration. Now what we're doing is we're looking for errors in this data set, and a couple of ways that I will do that would be, first of all, just looking at concentration versus time plots. You can look at individual plots, but usually group plots, you'd see like an outlier somewhere. If there's a point way off to the side, it becomes apparent pretty quickly. Another, useful plot are these index plots. So you basically plot ID versus each variable. And what you're looking again is for deviations from the group. So this is nominal time, actual time, and I see something a little strange there. Now this might be a little subtle, but that was the intention. Sometimes these errors are not so easy to find. Now essentially here I have 1, 2, 3, 4, 5 nominal time groups, and when I click on actual time, 1, 2, 3, 4, 5, maybe 6. So there seems to be possibly some, error between actual and nominal time. And if you go ahead and open this file in the spreadsheet, the first error is indeed in your nominal time column, it looks like there's a duplicate of 1 and 1. So maybe kind of a subtle error, but really when you're embarking on this type of work, really take some time to search for errors in your data set. So this, obviously the solution here, it looks like there's either a 0.5 or 0.25 sample. So it would be, okay, go back to data management or the protocol design, and decide what this nominal time needs to be. We'll use actual time in the analysis, so we're not going to bother correcting it. But that was an example of one of the errors. Now, the second error, which was in the homework file, and I'll just open that. I'll just open that up. Okay, yeah, there. I thought I provided, and someone could correct me if I'm wrong, a data set that had values in the concentration at time 0. And I just wanted to point out that, you can't have concentration observations and amounts in the same row, because the concentration would be ignored. But it looks like somehow the data set got switched in my version here, but okay. So are there any questions on, in general on data sets and error checking? Again, that's, the rest of this data set looks okay. Time, concentration. Any hands coming up? All right. Well, no, okay. So B, using the data inspector menu selections and exporting ggplot2 code to R, produce the following plot. And what we're trying to do is produce a plot that looks like this here. So
Keith, sorry.
Go ahead.
Sorry. Yeah, I think there is a question in the chat.
Okay.
It is from Srinivas, who's asking, how about number of subjects?
12 subjects and I have 16. Yeah, something happened with my data set here. I apologize. I'm not sure what, if I go back. Yeah, there's definitely 16 subjects in this data set. I believe what I did is I started the homework with a different data set, and then I forgot to change the subject number. Again, I apologize. No excuses. But yes, that's a good catch, actually. There are, in fact, 16 subjects in this data set. Yeah. Okay. Good catch. My error. Again, thank you for pointing that out. Yeah. Yeah. Okay. All right. So if there's no further questions on that, and no one's found any other silly error that I made, that should have been 16. What we're going to do is use the export ggplot functionality to produce this plot. And you see there's custom X and Y labels, a title, There's maybe a different color scheme. So let's see what was done to produce this. So essentially, we can get kind of close, right? Where one of the things that you may have noticed is that in your data set, remember the data sets are a row by row recreation of the dosing and sampling history in a subject. So for that data set, your dose records will generally have a 0 for the dependent variable or the concentration observation. It's not a real observation. Sometimes users will use a dot, but when you're graphing out that data, one of the things you want to do if you only want to look at observed concentrations is strip the dose records from your plot. And it's maybe a bit hard to see down here, but there's a point at time 0, and it really stretches out the x-axis. So in Piranha, you have the ability to filter. So we can basically, select amount equals 0. And if we pop open that data set again, essentially you see this is a dose record where an amount of 2,500 was given at time 0, right? And the concentration is 0. We want to strip these out. So how can we do that? We can filter amount equals to 0, and then it'll strip out all these 2,500 dose records. So that's what we're going to do in Piranha. We hit filter, and you see that disappears. We already selected a log axis, right? Because we have a log axis here. And I think that gets kind of close. So how do we get this over into R? Again, as you make adjustments to your plot with the data inspector, Piranha returns the R code and different flavors to generate this plot. Base R, so that's R without the use of any packages. There's a lattice package that was kind of predated ggplot. But ggplot is probably, if you need to pick a graphics package to learn, it would be ggplot. So we select ggplot, and then we can click on this R button to open the code in the R GUI. And essentially, this is the code that's brought in. Now, if you go ahead and just try to run this, well, it ran for me because I already have my working directory set. This set working directory, when you initially have a project in Piranha with no model file yet, Piranha doesn't know where to set the working directory. So within R, you basically want to point to the directory where that data set is. And you can either type in the path manually, or in R, you can go to files and essentially navigate to that working directory. So if we, just make sure I'm going to go to the right one. If we go to C data, again, Piranha, it's not the right one, training, project D, homework 2, and say under more, set as working directory, you see this code comes down here, set working directory. And again, this just tells R where to look when you begin to execute code. So we can copy this up here, paste, and now we can, yeah, I copied too much. Get rid of this. We just want the path. Set working directory. C data Piranha training. Okay. So now we run this, and we get something close to our plots. Now, again, I prepared the homework ahead of time, so we're going to take a look at how we would modify that code to create the plot in the homework. So this is the same plot. We have the xlab and ylab commands. That's how you add labels to a plot, ggtitle, and then this theme black and white. And if I just run this code up to here, right, that's the default that we got from Piranha. What I've done is I've added an xlab that adds my X label to change time to hour. I've added a Y label that changes my plasma drug X micrograms per ml. And I've added a title to that. Now, I suspect people who were able to approach the homework probably got there pretty quickly. Where it became a bit more difficulty was, okay, how do I get rid of this gray background? You know, in the Word document, it's white. How do I get rid of this gray background? And in R, you have the concept of themes. And basically, a theme is a way to customize the non-data components of your plots. The titles, labels, fonts, backgrounds, grid lines, legends. There are a bunch of built-in themes within R. We can take a look at a few of them. One of the ones I use fairly commonly is this theme underscore black and white, because it makes for plots that appear you know, well in a Word document. So if we just apply the, we can really just run the ggplot component of this. If we run the plot with the theme black and white, you see it gets rid of the background. And there's other themes. You know, we can look at you know, just one or two of these for ha-has. This would be the dark theme. Of course, if there's any questions on, you know, anything in R, you can just type a question mark theme, right? That'll bring up a help menu. And, you know, here, this gives you an idea for the flexibility with which plots can be modified by use of the theme. So are there any questions on that? Again, it's, you know, it's touching on functionality of ggplot and showing how Piranha gives you a good starting point for code to produce what you need to produce. Are there any questions? Would people like me to cover a bit more of the R component? I think one thing that may be useful, if I go to my my slide deck here. So generally speaking, getting help in R for any function or package in R, help is available directly from the command line. And, you know, you access that by, you know, help with the function name or help with the package name. And, you know, we can take a look at read.csv, for example. If we go back to our R console, say you're trying to read a file into R, you can do help read.csv. And what comes up is this help section in R, okay? And, you know, when you first start using R, at least when I did, one of the things that frustrated me is that, you know, I always wanted like a direct example of what I was trying to do, and I didn't necessarily always get that. And all I can say is the help becomes more useful the more proficient you become with R. And again, this is just default, the way that R works. And if I go back to my slide, you know, essentially the standard convention for these help displays that I'm showing is to return a file with the following sections, where there's a description, which is a brief description of the function. So for read.csv, it's actually read CSV as part of a generic function called read table, where there's the call to the function and then a bunch of options. But here's the description: reads a file in table format and creates a data frame from it. Okay, so there is a usage. So the syntax for calling the function with a list of all the function arguments with the defaults. Every function in R will have a set of defaults that generally, you know, the idea is that, okay, if you run the function with the defaults, you should get the answer you need, but every function has arguments that you can specify to make that function do slightly different things. So there's a usage section, then there's a description of each argument. If we go back to R, here's the arguments. So file, it's the name of the file that you want to read from. Header, does your file contain a header, true or false? So the whole list of arguments. And again, this is for any function in R. The details section will take a deeper look at the arguments. So again, for each argument, if there's important like details around that, they'll be in the details section. See also would be a list of related functions. So if you're trying to do one thing, you have an idea, you can type a function name in. Often you can look at see also and maybe get a more direct answer to what you're looking for. And then finally, by and large, the most useful part of the standard help files in R is the examples. So usually they're at the very bottom. And if I go back to my R session, way down the bottom, you see you have these sections with examples. Probably 7 times out of 10, you'll be able to take and just copy this example and then get to where you need to be. But that's like standard help in R. And again, I apologize that this is kind of basic, but I realize a lot of people are just very, starting with R, and yeah, it's hard. So there's other areas for help. There are package vignettes on this website called GitHub. And this is where the developers actually, have all the code for these open source packages that run in R. And we can take a look at some of these actually. And then finally, there's Google. If ever I have a question or something isn't working in R, very often I can type in R, the function that I'm working with, and then even the error term that comes out. And almost anything that you will try to do, you can find examples for in just by a simple Google. But to give you idea of what the help in GitHub looks like, if I just pop in, I had this link in the presentation materials. So this is the help for Certara RSNLME. It goes over the packages. These help files are hyperlinked. So if you, they have usage examples. And again, this is an example of a package down website that is more kind of targeted towards providing reproducible examples for code. If you hover over some of the commands, for example, here, PK model, and this is command line RSNLME. This would be the command to create a 2-compartment model and map to your data set from the R command line. But you can click on this and it brings you to like the help file for that. And there's also vignettes. The concept of a vignette, it's like a story that shows you how to use a particular package. So there's a number of ways to get help with the packages, and I hope that very kind of brief summary was helpful for folks. So I think we can go back to the homework now. See any hands popping up. So what would be a reasonable starting PK model? So again, looking at this data on the log scale, it looks like there's a distribution phase followed by a more shallow elimination phase. Probably start with a 2-compartment model. On this, of course, it's IV administration. And that's what we're going to code up in the model builder. So use the new model builder to reproduce the MMDL file below. And what we have is, essentially looking through the code, we're using microconstants. So again, we could write this in the form of differential equations, but PML has the ability to use just the flat out equations, which run a bit faster, and that's what we'll do. That's what's done by default for many of the models. We're using looks like a multiplicative error model, C times 1 plus C, the epsilon on concentration. We have random error terms on volume and clearance, not on V2 and CL2. We've added some covariates, weight, gender, age, and we've set some initial parameter estimates, 15, 5, 40, and 15, and some diagonal eta block with initial estimates of 0.1. So let's go over to Piranha. And we can close this out now. And we'll go back to our homework 2, because I've already done it in the homework 1. What I'm going to do is actually save this. I'll call it homework 2. And why do I want to do that? Because then it becomes available as a should. Come on, cancel. Homework 2. I didn't save it. I hit that. I want to save it. Homework 2, save. So now I have a quick link to it. I can get to it fast. Homework 2. Okay. So we're going to go to models, new model, model builder. I'm going to make sure that my data set is selected. So homework 2, pkdata.csv. Going to run the model builder. Now, if you were skilled in PML, you don't have to use the model builder. You could just write, maybe take an example MMDL file and write it from scratch. In fact, that's the concept that people use when they work with non-mem, right? You have a control file that you edit manually. The model builder is essentially just a tool that allows you to write PML code without not necessarily understanding the details of the syntax. So we have a PK model. I think I covered before, there's many different kinds of models that are built in to the model builder. We're actually adding delay functions in the next release. So these like distributed delay models for absorption, this kind of thing, but I don't want to digress too much. The number of compartments, we are going to start with a 2-compartment model. It's linear elimination. You can, have Michaelis-Menten if you like, and the absorption is intravenous. And we are going to stick with a multiplicative error model. Again, there's, additive error models that might be appropriate for a PD model. I think Serge covered some of that. There's a combined additive multiplicative model. So that behaves like a proportion or multiplicative model down to perhaps the limit of assay sensitivity. Those are fairly common, but usually you're safe to start with a multiplicative model, particularly if you're working with PK data where your concentrations are, ranging over, maybe 3 log type range, just as a general guideline. So we have no lag time. Under options is where you could reparameterize or use differential equations if you want. We'll just leave it with the closed form. So now we hit next. And these are our structural parameters. Right now, the random effect terms are on all 4 of the parameter estimates. If you recall from our example, we wanted to remove those from V2 and CL2. So where am I? Go back to my model builder. So that's simply just unchecking it here, and you see it disappears from over here. Covariates, we wanted to add a couple of covariates. I think it was weight, gender, and age. Go back to our model builder. We click on this plus. We can select on the covariate. Again, if it doesn't appear here, you can always look at your data set. So we have weight, gender, and age. Just go back to PML so we can see the code changing. And we're going to pick weight. It's a continuous covariate as opposed to a categorical or occasion. Again, going back to the homework, how did we do this? Okay, we're just adding it, and we're not applying it or centering it yet. So go back. Now, just to what we're doing here is we're adding covariates, and I think it'll become clearer in next week's lecture. We're adding covariates, but we're not actually going to estimate their effects on any parameters yet. We just want them available in the model so that we can call them in diagnostic plots. And this is very common. The first runs that you do, you will run your base model with no covariate influences, and you will generate individual parameter estimates. You can also look at eta terms, but a gross way of doing it is to generate individual parameter estimates. And then what you do is you plot individual parameter estimates against your covariates. And you can see patterns that suggest that you may have a covariate that influences a parameter value. So what we're doing now is we're just adding covariates to the model, but we're not going to add, estimate an effect on a parameter yet. We just want them in there so we can run some diagnostics with our base model. So I think there's a hand up. Yep.
Yes, yeah, I was just about to point that out. There's a hand up. It's Srinivas. Let me unmute you, Srinivas.
Am I audible, Keith? Good morning.
Morning.
Yeah, Keith. Actually, could you please repeat how to, include this covariates, because in my app it is not coming. So could you please repeat it again? Covariate
Okay.
adding that weight and age and sex, I guess.
So if I go to the previous window, so the model builder, you launch it, and then you select kind of the basics of your structural model. And we selected 2-compartment linear intravenous. Then you hit next. And the first dialog that comes up is the structural parameters. And at this point, you don't hit next. You click on the covariates tab.
Okay.
And then you click on this plus button.
Okay.
And you should get a dialog like this.
But here it is not coming in the dialog box. Weight, sex, food. It is not coming in my app. I don't know how.
Do you see your data set if you click on data?
Yeah.
So, Srinivas, this may be a more involved question. You might have to work with Mauli. Am I getting this right, Keith?
Yeah, if you're free, yes. I think set up a meeting with Mauli. I'm free after this session if that time works for you. I don't know what time zone you're on. If you don't see the drop down, you can just enter it, type it in. So in this case, age isn't here. Is that the problem, or you're not able to? I guess I have to see what the issue is to understand a bit more.
Yeah, actually in the covariate, this drop down box, it is not coming age. So no issues. I will contact with the Mauli and I'll go through.
Okay,
So
yeah,
I
if
think-
it doesn't appear in the drop down, you can manually type it in.
Okay, okay,
Hey,
okay. Thank
Keith.
you.
Yeah.
Thank you.
Keith, this is Tom Jones.
Hey, Tom.
I think what's happening here is you have typed wait before and it's just giving you suggestions. This is just the
Yes.
browser. So it's just
Yeah.
what things you've typed before that's suggesting. So when people come in here, they will not see those suggestions. They'll have to type them in.
Yeah, that's correct. Yeah, I'm sorry. I
Okay.
thought I made that clear.
Yeah,
Yeah.
okay.
If
That's what's
you're
going
working-
on here.
Yeah, if
Thank
you're
you,
working
Keith.
with a
Thank you.
brand new data set, you won't have any drop downs.
So Srinivas, are you able to type it in? Is it working for you now?
Yeah, actually I'm type in, but age it is not coming. Even
No,
sex
you don't,
also-
nothing. So Srinivas, nothing will come by. So you just type, you see where Keith is, where in the covariate, the first column, just type in age. It will
Yes.
not show up as a drop down. Just type it in.
Yeah,
And then what you should see is this.
yeah, thank you. I got it, got it.
Okay.
Thanks.
Yeah,
Thanks,
please.
Keith.
Yeah. Again, anyone has questions, we're more than happy to spend as much time as needed to
I know it is a very primitive question. It is a basic fundamental. So because, when I'm, going through the app and also, so that's why I, face this problem. So immediately I wanted to ask. So that's why I raised my question. Sorry. Go ahead.
this. Again, I want to, reiterate to the group, I'm very grateful to have this opportunity to be having these discussions because it's going to help us build, better tutorial materials, and really, hopefully help beginning users be able to get proficient with R more quickly. That's one of my goals. Again, help people grow, and this dialogue is very helpful for that. So, okay. So we've added age and weight, and the final one we wanted to add was gender. So if we click again, it just appears in the drop down because I have it there, but I can just type in gender or sex. This is a categorical variable. So I'll select categorical. And then what it asks me is, okay, how many levels? And for sex in my data set, it's 0 and 1. So again, it's pre-populated because I've worked with this before, but if it wasn't, I would just type in 0 and 1. And then I assign some labels. You can see I worked with a data set in the past that had a race column, for example. There's no race in my data set, but it appears. Maybe a bit confusing. I think that's a general like display issue. So male, female. And again, I'm not going to add it to any parameters at this point. So that's my covariates. You see for categorical, it's a bit subtle, but the way that PML understands that covariate is categorical versus continuous is by this additional set of parentheses. Again, it's a PML syntax issue. But if you were writing this from scratch and you wanted to add gender as a covariate, the additional parentheses indicate that is a categorical variable for PML. The next tab that I navigate to here is the fixed effects. And this is where I enter my initial estimates. If I like, I can put in lower and upper bounds. I could skip this and then, modify this later on. I think that was a question earlier. Maybe I'll do that. I'll just leave that as 1 for now, and go to random effects. And for my random effects, I just want an ADA on volume and on clearance. And I'm going to leave that diagonal. I won't look for any kind of correlation between those. And I'm also going to change the initial estimate here from 1 to 0.1. We probably should make the default 0.1 for these ADA terms. I think the 1 just comes from the defaults that are, available in Phoenix. That's probably something we'll change. You have the ability to freeze ADAs if you want. So next. Now this is where if you had, I guess we're working with a very simple data set, right? It's a single dose data set. Very often in these population analyses, you have, you're combining multiple studies, some of which may be multiple dose, some may be single dose. You have the ability to use other data columns to indicate whether or not sampling after a dose is a steady state sampling event. The ADDL column definition, you have the ability for a multiple dose study. If in the data set, I can just explain this quickly. I don't want to get in too deep, but if I had an ADDL column here, and for this dose, it's given 25,000, I guess it's probably nanograms at time 0. Now I could type in a 3 here, for example, and I would also need a column called II, which is interdose interval. And I could say 24. And what this would do would say, okay, I'm going to give this 25,000 dose at time 0, but I'm also going to give 3 additional doses separated by 24 hours. This gets into data set preparation for population analyses. And again, I think it goes beyond like the remit of this course here. There's user manual material available for how to do this, and that is again kind of explaining some of these additional features in. I'm not going to save this in the model builder that we're just kind of skipping over. So we're not going to use any of that. The final step is the column mapping. And I shared that slide previously. I'll share it again. Column mapping is simply telling the RSP or NLME where the variables are for the model. So the model is expecting, in this case, it's a 1-compartment IV bolus, an ID variable, a time, a dose variable, and an observation. And the mapping process basically just says, okay, in my data set, ID is actually ID, time is time. I think this should be clear. If there's any questions on that, yeah, please raise your hand. But here it's just a matter of going down and checking the boxes. Time, we're going to use actual time. Observation is concentration. Weight, age, gender, and A1 is amount. But now we're essentially ready. If I just expand this a little bit, we can hit save and exit. I also showed that you could, at this point, generate the command line code and just move over to R outside of Piranha, but we're gonna use Piranha. So if I hit save and exit, go back to Piranha, hit refresh. Here's my model. Now, if I double click on it, here it is, and this should match what we have in the in the homework. We have a description of run 1. Piranha allows you to add notes to your code, so we can type in run 1. This is free text. You can basically name it as you like. So hit save. All right. So any questions on the model builder? We just specified a 2-compartment IV model that we can now fit in Piranha. And that is that's the next step. So number 3, fit the model. So that's what we're going to do. So now we're going to right click, and we can fit this model directly. And that's what we'll do. So here you see where some of the configuration comes in, which is, again, the complicated part of the installation. The NLME directory is simply the path to the engine executables that were installed. I have my working directory, which comes from, the path that I'm at here. And we just hit the blue button here. And now what this does is it launches NLME, finds a license. This should be pretty quick. It's relatively small model. Just runs through the estimation routine. Oh, you know what I did? I left all my initial estimates at 1. So we'll see how much data is in here. We'll see what the fits look like. I actually did that unintentionally. So it looks like it converged. Yeah, but see, my initial estimates are way off, right? So that's a good example. If we look at the code, remember I said I was going to leave these at 1. So these are kind of way off from what they need to be. And the algorithm tried to converge, but I believe if we look at the fits, these are not going to be too impressive. Why don't we just start with a simple DV versus pred. So that's pretty horrible, right? Here's the line of unity. And you see the points that we have are very, very far off from that. So that's easy to fix. We'll simply reopen the model. And then for our estimates, I think we had a volume of 15, clearance was around 4 or 5. Volume initial estimate was around 40. And then this is around, I don't know, 15 or 16. So we can simply just save that and then rerun it, fit meta model. Run this again. Okay, so that's done. Hit refresh. Now we have estimates, kind of closer to our initial estimates. Again, this interface in Piranha is intended to give like a quick overview, a quick summary of the model fit. So you have your parameter estimates. This little bar graph, the little green bar will show you, how close your final estimate was to your initial ones. In this case, we're all pretty close. If you hit a boundary, in other words, if you supplied lower and upper bounds for volume, and during the fit, the algorithm was trying to push the parameter estimate beyond your boundary, what you would see is this line way over to one side, and it would be shaded red. And also you'd get a flag in this B column that says, 1, I think. That means one of your parameters hit a boundary. So the Piranha interface is, it's intended to give you just like a quick summary of your run. These in parentheses are the standard area of your parameter estimates. So, interpret that. It's like volume is 16, but it could be 31% higher or lower. The numbers in brackets near your omegas, it's kind of up on the side here. This is your shrinkage. And again, I described shrinkage a little bit in the last lecture, but basically that's an indication of how much data in your data set is there to inform that parameter estimate. And if shrinkage gets very high, it means your parameter estimate is shrinking towards the population estimate because there's not enough individual data to pull it in a different direction if, you know, an individual is different than the population. I think again, I'm touching on concepts that, you know, you could give full courses on. I think I gave some very good references. Mold's series of papers on population PK analysis discusses shrinkage and, you know, a lot of the concepts that we're talking about here. I highly recommend those as like a starting point for population PK. So these are our parameter estimates, and then what we can do is run our scripts. And if we go back to our homework, well, what are the estimated values for clearance volume, CL and V2? Of course, we saw that in the Piranha interface. Are the between subject variability terms for clearance and volume precisely estimated? I think we did have an issue with volume, right? 730% is quite a large CV on volume. So what is that saying? It's saying that there's not a whole lot of data in the data set to be estimating the between subject variability term on volume. So no, that is not precisely estimated. And there's high shrinkage too. So that's an indication that your data set is not, the sampling times aren't, you know, the best to inform that particular parameter estimate. So now we can go and run some scripts. I think that was the next part of the homework. Using the default diagnostic scripts in Piranha, produce the following diagnostic graph. So this is just a combined goodness of fit plot, and that is available right here in Piranha. So there's this one. All right, and this is a good, the DV versus predicted, the DV versus individual predicted, and then your weighted residual plots or conditional weighted residual plots are a good kind of first look at overall model fit. And what you want to see in these plots is essentially featureless even distribution around the reference line. For DV versus pred and IPRED, the reference line is the line of unity. So, you know, intercept of 0 and slope of 1. A perfect fit model would have every point aligning exactly on the line of unity. That never happens in practice, right? But what you want to see is what you see here. This is like a good fit. We could run, or I encourage you to run a one compartment model and compare like the diagnostics. And for a one compartment model, what you would see is probably deviation because you'd miss the peak. You'd see this curve kind of peel up here. But again, these look pretty good. Yeah, not much else to say on that. There are a number of default goodness of fit plots available in Piranha by default. Each and every one of these, sorry, is there a question? No, okay. We can just run a couple of these. This is individual plots showing DV and IPRED. So the model looks, you know, it's doing a decent job. And you can just go through and click on any one of these. Are your ADAs normally distributed? You know, that's something you want to check. The assumption is that they are. Again, this is a relatively small data set, 16 subjects, probably, you know, good for training, but you'd have to be cautious about any conclusions you draw from a 16 subject data set that you are running a population analysis on, simply because 16 subjects is not, you know, it's not a population. So if you, for example, didn't see a weight influence on volume in your covariate analysis, maybe your weight range in that 16 subject data set is too small, right, to be able to show that kind of relationship. Again, maybe a bit off on a tangent, but things to think about when you run these types of analyses. So yeah, there are basic goodness of fit plots. These are all written in either base R or using the lattice package. We also have the expose plots, and these are written in the ggplot syntax. So I think we're going to take a look at one of these in the next part of the homework. So yeah, I'll leave it to you to go through and explore some of the other diagnostics with Piranha. But the final step in the homework was to create this graph by editing the default expose DV versus IPRED diagnostic plot in R. And this again kind of shows the, I guess, the flexibility of bridging from Piranha into R to customize your plots to get them exactly the way you want. So in here under structural diagnostics, we have this DVA versus IPRED. We can just double click on that, and it'll bring up the plot. It should. Here it is. It was too quick. So there's like the default DV versus IPRED. Maybe that's close to what I want, but I want to modify it. And again, what we did is we split it by gender, added a custom title. So let's take a look at how to do that. Cancel that. So what we would do, I'm just going to close this PDF out too. What we do is we right click on this and we'd say open script in RStudio. So here's the script. There's a little preamble, talks about the required files. One of the things that Piranha is doing in the back end is it's creating this JavaScript object notation. And that's essentially a file that's human readable, but can also be parsed easily by programs. So Piranha is doing a lot in the background to kind of reorganize the output from a particular run to make it suitable for generation of diagnostic plots. With these scripts, you don't really need to worry about the front end of it. So here, this is the Piranha scripts. You're able to select more than one model and run a script. And what it will do is it'll generate the same diagnostics for multiple runs, thereby allowing easier comparison across runs. And that's what some of this is doing. It's saying, okay, the models, there might be a list of models, not just one. In my case, we're only using one. So what I'm saying is you don't need to worry about this code, just leave it alone. You won't be editing that part. That's just standard, bringing the model information into R so that you can run it. This is directly executable. If I select the whole thing and hit run, what it's going to do is it's going to give me that PDF file that we got from double clicking on the script in R. So it runs directly. Now, what we want to do is modify the call to the plot code. And essentially, I have this already done in my homework. So let me just run this again. Let me run this again. It's down here. So here's my R script. Like with Piranha, if I run this. Oh, here, let's see how I'm going to do this. All right, I'll just redo it manually. Let's redo it manually. I think this is the one. Sorry, I want to make sure I'm running the right one. Control A. Okay, so this is the right script here. Now, Piranha gives it like a temp name. After you modify this script, you can save it to a reasonable name and then use it to rerun. So if you customize like a DVPred for your particular analysis, you can actually make that script available for your next run. So you customize it the way you like, and then you just run it against all subsequent runs. And that's a really powerful capability of R. Again, the ability to customize your diagnostics to your particular modeling problem. But what we're going to look at is just take a quick look at what can be done with the expose DV versus IPRED. And in this code, you'll eventually come to the place where the way Piranha works with expose is that we have a function called expose NLME. And what expose NLME does is it takes the output from a given NLME run, RSpeaks NLME run, and it creates an expose database object. And this expose database object can then be fed to various functions. In this case, DV versus IPRED. So here we're saying XPDB, we're going to create this object by running the expose NLME command. And essentially the command requires a directory to your model directory and then the model name. This code is written in a way, again, to support multiple models and to be more generic. If folks are interested, you can type on # expose NLME and it'll give examples of how to, run this manually. But we're running it from Piranha. So we create the XPDB object, and then we can run the DV versus IPRED against it. And if we just highlight that part of the code in R and click run, R will run just that part. And now you see, instead of generating a PDF, it generates a code in the plot area. So now I can play with this and get this plot the way that I want it to look. And one of the powerful things about ggplot is the capability of faceting. And here, by default, the facet is set to observation name. We only have one observation name. If you had a data set with more than one analyte, maybe PKPD, where you have a concentration and effect, this script would automatically split the plots by concentration and effect. In our case, we only have one analyte, but what we want to split by is gender. So if we change facet to sex and hit run, now we have two plots, one for males and one for females. It's also possible to facet by continuous variables. A very quick and dirty way is to use the cut command. So if you do cut weight, 3, what this is going to do is it's going to split your weight variable into 3 cuts with an even number of observations in each cut. And we'll just take a quick look at what that can do. So faceting by continuous and categorical variables is a great way to dig into how your model is actually fitting, the various pieces of your data. Maybe it's a center effect you look at. Maybe it's an occasion, right? Faceting by occasion can see if your model is, fitting well across various equations. The ability to facet is probably one of the most common kind of tools that I use when I'm looking more deeply into, how my model is performing. And again, with the expose package and RSpeaks NLME, it's really quite simple to do once you understand the basic syntax. So I'll change this back to gender, and we'll just take another quick look at our plot in the. So we have the gender. What else do we have? We have a custom title up here. So we'll go back to R, and let's see. Let's just get back to our gender. The other thing that's helpful is, we brought the DV versus IPRED over, right? There's also a DV versus PRED. So you can, you don't need to stick to exactly what that code was that was brought over from R. So here's DV versus PRED now, faceted by gender. So it's quite flexible to be able to do pretty much whatever you want to do. So the syntax for the title, I'm just going to go to my my homework and copy this in. There's a couple of other things we did here. Let's see, we need to discuss the type. I'll just copy this in to our script here. So the type command, get rid of this. So the type command in Expose is the type of plot. So the P and the S stands for points and smooths. There's also an L, so point smooth line is the default. Let me just run this here. Point smooth line, we run that. Now we have, you know, this plot, if we want to get rid of the lines, you just remove the L. Run. You can see you can just play with this and run it until you're satisfied with the plot that you want. So we'll leave that at point smooth. Again, I got rid of the lines for this plot. And then titles. So we'll get rid of this parentheses. And so if we look at the help for DV versus IPRED, and the way we do that is question mark DV versus, and it comes up, you can just highlight it and hit enter. Brings up the help, and here is the usage. So there's the call to the command, the Expose database object. Additional mapping is possible, but we won't get into that. Group equals ID is a default. That's generally what we want when we're looking at these types of population analyses. We covered the PLS, right? So in the default call of the function, it's points line smooth, and we saw that. And then we got rid of line. Now, title by default is what we see here. And it's saying, okay, the title is at Y versus at X. Now, what the heck is this at Y versus at X? Well, this is a concept within Expose called template titles. And template titles are, you know, a way to create very informative plots by extracting information from your model object itself to populate the title. And if you go to template titles, so the help for that, you see a list. So in this title syntax, when we're entering at Y, what it's doing is it's pulling in the name of the variable used for the mapping. So if it's DV versus pred, it's going to be, you know, basically at X is DV and at Y is pred. The at run is the run number. And there's a bunch of other ones, right? You can, you know, bring in a software version, name of the plot function. I will kind of make the comment that Expose was originally, actually, it's still, Expose is developed for around non-mem. It's been around quite a while, and it was developed to support diagnostics for non-mem. So there are some template titles and also some like Expose functions that don't work for NLME, usually because NLME doesn't have that component of the data to inform it. So if you come across something that doesn't work in NLME for Expose, that's the reason, because it was built for non-mem. But for most of the common diagnostics and common template title information that's in there, it works just fine. So, so what we've done is basically modify the title. So we copied the, again, all I did was copy this title information in here and then modified it. So here, this is my custom faceted plot. I put in a new line. That's like a carriage return, the \n. And then at Y versus at X with the at run, and I added number of observations, I think. Subtitles, the objective function, and the caption is the directory where the run is. And if we plot this, I think I might have an extra parentheses there. When you see an X in RStudio like this, it's saying, wait a minute, something's wrong with your code. You see here, I have an extra parenthesis. As you learn R, that type of little error will frustrate the heck out of you. All I can say is, you know, as you get more proficient, you'll get quicker at, you know, finding those types of errors. And by all means, if you have questions, reach out, because often a more experienced R programmer can look at a piece of code and see things immediately in you know, a minute. Whereas if you try to figure it out yourself, it could take, you know, quite some time, just the nature of command line languages. But if we run this now, that's our plot. So I think I'll stop there. Hopefully, you know, the homework gave you a bit of a feel for, you know, the types of things that you can do with Piranha and the bridge over into R. Again, it is possible to do all of this from the command line. At the next lecture, I'll be sharing, you know, an example of doing that. Essentially, a complete workflow. Maybe give you a taste. It looks something like this, right? You read a data set in, you can make some plots. You define your model. You customize your model by removing ADA terms from CL and B2, setting fixed effects. So there's a set of commands that you use at the command line that do what is done in the GUI. If you return the R code from the GUI, you'll see this is the type of thing that's returned. So you define your model, you fit your model. You can create a run summary table manually. We are building tools to do that more automated, which I'll show you next time as well. And then essentially here is where you create your exposed database object and you can run diagnostics. So that's just a quick script that reproduces what we did through the GUIs in Piranha. And I could just run that all right now and get my results. And I think that, you know, that the ability for you to work in that type of capacity is what gives like very advanced pharmacometricians the efficiency that they have to be able to do large analyses and produce reports very quickly after the analysis is done. And I'm really hoping that the tools that we've developed are going to help users that have struggled to kind of climb that learning path to get to that point. So are there any questions? I think we have a couple of minutes left. I hope that was useful.
Thank you so much, Keith. This is very, very helpful. If you have any last minute questions, please raise your hand so we will be able to unmute you. And again, you know, you can practically walk through the, as Keith has shown you step by step, you can walk through the homework assignment that way. And we are not holding this against you. We are just here to support you so you can get a feel of using this. And I see Mauli has his hand up. I am going to unmute you. You should have, yeah, go ahead, Mauli.
Okay, I've just worked with some of them. They're having some GC Fortran error when they're trying to run the script. I think I identified the issue, and if anyone is having that issue, please contact me. I'm happy to work with them to get it resolved. I think there are 3 or 4 users having this GC Fortran issue. Just letting them know if you come across these GC Fortran issue, it's easy to resolve. Okay. Thank you.
I think we have one more hand up. No, it went down. Okay. So I think we are going to end the session here today. Thank you all. And we will be here to help you address any questions or concerns that come up. Feel free to reach out to us via email, and we can also, Mauli, if you can please put your email again in the chat box. That way the participants can reach out to you directly if they have any questions. So that's all for today. Thank you all for being here. Keith, did you have anything to add?
No, just to reiterate, please reach out to Muli. And again, thank you for the opportunity to let me share and for the feedback.
Thank you all. Thank you for being here, and we will be in touch with you for the rest of the week. So next week, the plan is that we would be bringing your learning with RS and LME to the next level. And we look forward to seeing you at the next Friday's workshop. Thank you all.